Okay, great. Let's start. Let's begin. Good evening, everyone. If you don't hear me well, let me know in the chat in YouTube and I will adjust my mic. But I assume that everything works fine. So, welcome, everyone. My name is Vlad. I've been working at Axon for 5 years and I'm a software engineer. And right now I'm leading the front-end chapter. My job here is to develop a solid front-end community, and my programming path was all about learning from mistakes, doing experiments, and right now I can genuinely say that my colleagues and we care about the quality. And I want you to care about the quality too. That's why I'm here. Today I will tell you about the frameworks, the languages, the people, the projects, so stay tuned and let's move on. I must say a few words about the company where I'm working on. It's Axon. Axon is a software development company, and over the years we've grown to 140 people and we finished over 100 projects. And our clients are worldwide. They're from Australia, from Europe, from the United States. So I'm proud to work here, and I will tell you about the stack, the technology stack we use at Axon, the projects we have at Axon, their types, on the next slides. So I just say that we care and you should care about the project quality. But why should you care? Let's explore it. Yeah. First of all, we claim that our customers receive not just a working solution, but one that will live for years. It's nearly impossible to be on the edge of technology forever. But there are some tricks that we know, the tricks that can minimize the speed at which the legacy code appears. The second point is that building a strong technical stack requires knowledge of the overwhelming number of concepts in computer science and web development. We will discuss whether computer science can benefit the front end or not, maybe not. Then the JavaScript fatigue is expanding and has no signs of collapsing. Software development companies essentially have two choices now. The first one is to accept their failure to keep up with the evolution, to get bogged down in the legacy environment. And the second option is to actually learn modern tools and apply them. But there is a trick with the latter. We need to find a way how to determine if some technology is a failed experiment and will occasionally die soon, or the other way around, become an industry standard. Yeah, so let's move on and define the webinar goals for today. If you came here, I assume that you want to get some tips. Maybe you dream of a project that will never experience issues with the front-end part. I will share some ideas and try to convince you that, first of all, front-end development is not easy as it seems. Then, choosing the proper front-end tools can save you money despite of the project size. And third, failures will happen anyway, but we should find a way to be proactive to prevent them. Let's talk about how important it is to find the most optimal tools for a front-end project. By the way, if any of you have any questions, let me know in the chat. I will read them and answer at any point of time. So just let me know. But we need to explore the global situation. What is the current status, current situation of the front-end environment, front-end ecosystem? First of all, the web development world is bloated with millions of published libraries. Most of these libraries solve the same problem in thousands of different ways. There are hundreds of web frameworks that claim to make developers more productive, but only tens of them are well known, and only some of them are well known by millions of developers over the world. On this slide, you can see that there are more than 2 million of packages in the NPM, which is Node.js package manager, and there are, wow, I don't know, this number is so huge, almost 200 milliards or billions of downloaded packages monthly. That's amazing number. Well, except the huge ecosystem, we must understand that changes never happen quickly. And if your team makes the wrong choice, the wrong initial choice, it will stay with you for a very long time. Most businesses cannot afford to rewrite the app from scratch. And that's why it's never a bad idea to spend extra weeks researching the problem area and researching tools to solve that problem. So spend a weeks, some weeks, it will be useful for you. It never harms. The third item. Strong engineers will prefer working with good quality code. If your project cannot boast of good code, which is concise, non-repetitive, documented, and scalable, they will run away. They will run away to the project that can offer a better option. The only developers who will stay are either challenge lovers who are not afraid of adopting a foreign code, no matter how scary it is, or average developers who actually don't care much about the code quality as much as they have a job. Well, there is a question in the chat regarding the taking notes. I think we will keep this recording after I finish, and you can get back to this webinar at any time. Maybe we will also attach the presentation, so there is no need to make notes. Let's move next. Now the interesting part begins, the complex part. We need to talk about the types and holotypes. I will explain what is a holotype. We need to talk about the most crucial factors that drives developers to choose one or another instrument. Well, before starting any development, you or your architect must create a plan. We must plan the system and decide the tools. And each type of the app has its effective tooling to deal with it. So what are types? We can categorize most apps, like front-end apps, or it doesn't matter. We can categorize them based on their common characteristics, such as domain model, amount of client-side business logic, amount of content, performance requirements, and so on. It all comes from the product's features and design constraints. And when we classify apps based on their features and constraints, we enable more targeted, more impactful solutions. So, for each category, we can determine a holotype. What's a holotype? It's the most bright representation of the distinguishing characteristics. If it sounds complicated, no, it's not. So, for example, when we see an app that has these constraints, thick client, page-centric rich media application with offline browsing and user contribution, we can throw off this difficult part and say just Instagram-like app. So Instagram here is a holotype. It's the most bright representation of characteristics. And I will provide some more examples right now. Let's see. So Facebook or LinkedIn or Reddit, all they are social networking destinations, social networks. And they all have common characteristics. They are multifaceted, they contain sub-applications, like sub-modules, some dynamic modules, they have infinite scrolling content, they have user contribution, so user can leave their posts, comments, post photos, videos, etc. They have real-time updates, and notification systems. This is only a portion of characteristics, but they are common to all of the types, all of the apps inside this type. Also, there are some constraints, some business constraints. We want our Facebook application to have an extended session depth. It's a large scale, meaning it covers millions of users. It should have real-time updates. It can have embedded content, nested applications, and very important, it should be optimized for search engines. And for these characteristics, for these constraints, we can find an ideal implementation, ideal technology. Actually, technologies vary, and depending on how experienced your team is, depending on the current hype in the JavaScript world, depending on many factors, you can choose different implementations. But anyway, for example, for Facebook, for LinkedIn and Reddit, we would probably like to use single page application with pre-rendering of shell and landing pages. It's purely technical concept. If you are not a technical person, you just need to understand what is a single page application actually, and you need to understand that pre-rendering is crucial for search engine optimization, and the rest is details. Another application of type and holotype is storefront. Storefront is about e-commerce. So imagine an Amazon shop store, imagine some Shopify based stores. They all have something in common. They have search, they have payments, filtering, sorting, they have a shopping cart, and they must have search engine optimization, so our users can Google it, Google some product and find it on your site. And in contrast to the previous slide, to Facebook, to different social networks, here we cannot allow client-side rendering. We need server-side rendering here. It's a purely technical concept, and if you're a programmer, you must understand what is client-side rendering, what is server-side rendering, and you must understand that it's unacceptable for storefronts, for e-commerce applications, use client-side rendering. No, we need to use SSR, server-side rendering. And one more example. Now from our experience, from Axon cases, it's worth mentioning that at Axon we create a vast variety of application types. We can create applications for real estate, for education, insurance, cryptocurrency, marketing, finance, many more of them. We don't do games, we don't do GPU intensive applications, some 3D rendering. No, it's not about our company, but we are very experienced in the rest of domains, including probably social networks and storefronts. But that's not the case that I want to show you. I want to show you the third type, the third holotype. Here you can see a hiring platform. It's a single page application. It doesn't require any search engine optimization. It doesn't require server-side rendering. It doesn't require pre-rendering now. It's just a single page application that can be absolutely fully rendered on the client side. It's highly interactive. Almost everything on this screenshot is clickable, and it has dynamic modules, meaning depending on your system role, you can turn off, turn on different modules, and the users will receive the updates in real time. So this is like a different type of applications. We've seen social networks, we've seen storefronts, and now it's like the dashboard / admin panel / interactive web applications. Completely different type, and we need a different type of resources, different type of frameworks to create such kind of application. And another example, it's a property management system. It contains a lot of different forms, tables, data visualization. The forms are really insane size here, like maybe 100 fields in a single form. It has advanced row management, and again, just like the previous example, this one, the Harvard platform, the property management system is exactly the same type of application. It requires exactly the same set of instruments to build it. So that is my idea. You need to define the types, all the possible types. Luckily, you don't need to do it by yourself, because you can Google for application types and holotypes. And then you need to understand the type of your application. And based on this, you can go next. You can start picking frameworks, you can start picking languages and different supplementary tools. So I hope you understood my idea, and if you don't understand it, let me know in comments. I will get back and repeat, maybe rephrase it. But now we are moving next. Assume that we know an application type. Now we need to pick a framework. And this is a very interesting and big topic to discuss. Let's do it quickly, briefly. So, do we need a framework, first of all? An obvious but important note. A wide range of applications doesn't require any custom development. This is out of scope of my presentation, but long story short, if you need a landing, if you need a portfolio, business website, blog, online store, that does not differ from thousands of similar websites, then probably you don't need a framework. You don't need a custom development. Don't bother with expensive development. When you need something custom that sets you apart of your competitors, there are high chances that you will pick one of the open source frameworks, one of the trending open source frameworks. But why not proprietary? Yeah, you know that all frameworks, all instruments, they divide in two categories. The first one is open source, the second one is proprietary, which are paid, which are private, you cannot inspect their source code, and so on. So while it is common, this slide. It's common to select a proprietary CMS or e-commerce platform where you can get all the critical functionality out of the box. However, when it comes to development, to custom development, a very small number of sites use private proprietary frameworks these days. This is because the number of specialists who know open source tools is way higher than paid software users. So you've chosen an open source framework. What's next? Oh yeah, by the way, don't even bother inventing your own architecture, your own framework, your own paradigm. Once upon a time, I created my own framework when I was young, and I was too lazy to read the documentation of the existing frameworks. I invented my own. It was in PHP, and it still works. There is a site that runs on this framework, and I'm proud of it. But don't do this if you're working on a commercial project. Please don't invent your own solution. And this picture on this slide, it's a joke. So you must also remember that you can mix custom development and the proprietary third-party services. There is nothing wrong to use the already built authentication system or questionnaire, or add a shopping cart to your system. That's fine. You can use one of the Amazon services. Amazon offers about 300 services, which you can just select, pay for it, and integrate into your application. So that is completely fine. But the framework itself, the thing that you use to write code, it should be open source. Okay. And now let's jump to the next important question: how to choose the open source framework. You must understand that modern applications, front-end applications, they are all the way around pierced by JavaScript. And those people who started their careers back in the day, they might argue that we don't need all this crazy amount of JavaScript to build a website. And that's true to some extent. We don't need all this crazy JavaScript until we realize the reasons why this tooling exists, why it evolves. The truth is that people can't live without challenges. They want to be fast, they want to be productive. They come up with a new idea to make their sites, to make the entire world faster and more productive. And if they're lucky enough, it snowballs. Big companies, they pick it up, the framework or the instrument, they pick it up, and then it eventually becomes mainstream. Or maybe it dies as a failed experiment, but often it becomes a mainstream, and now developers across the whole world have to use this tool because everyone knows it. There is high demand for knowing this tool, and it just snowballs. Yeah, you can't go back to the old good old PHP, the LAMP stack, which is Linux, Apache, PHP. Yeah, it would work, but it's kind of outdated. You can't find a lot of developers who can support, maintain the system written in the old stack. Yeah, so back to picking the framework. As a rule of thumb, for commercial projects, you should use only those trusted by millions. In the front-end ecosystem, pick one of these three giants: React, Angular, or Vue. Everything else is considered experimental. And if you have your senior colleagues who can incite you to use a new shiny tool like Svelte, Solid, or ClojureScript, which is a very, very specific tool, the ideas behind them are fantastic, but you must remember the consequences. You won't go fast because their ecosystem is immature, it is small, and you will spend a lot of money searching for the developers who can continue working on your project when your current development team disappears, when it leaves the company. So don't pick experimental things for commercial projects. That's the rule number one. And if someone offers you to build your next big, probably large-scale project with an experimental tool like Svelte or Solid, which are React-based oh no, not React. It's their own frameworks. Don't trust them. Yeah, that's my idea, my opinion. Now we have React, we have Angular, and Vue. How to choose among them? It's an old, annoying question, and it has dozens of articles covering it. Actually, there is no winner. It doesn't matter which one to choose. You should pick one of them depending on your team experience. These frameworks are equally capable of creating an app of any complexity. For example, the framework of choice at Axon is React, and there are no true reasons why. It's just a historical event that we chose React. It's a combination of right people, time, and fortune. Again, the framework capabilities are absolutely equal. However, there is one important thing that anyone should understand. The truth is that Angular and at some point Vue.js are very opinionated regarding their ecosystems and regarding their coding approach. It means that if you have two teams of developers who code in Angular or Vue, they can, even if they don't know each other, they can quickly adopt the project, the foreign project they have never seen, because the coding approach is the same. It's very, very similar. because the tools, the supplementary tools like routing, state management, navigation, or it's actually routing, the way to communicate with the API, it's the same across all the applications written in Angular, for example. But in React, we don't have this situation. React is considered not to be a framework, but a library, and it means that alongside the React app, the React code itself, we can install a lot of different supplementary tools, and it makes React very flexible. But it also means that the coding approach can differ significantly, not just inside the team, but across the teams, but even inside the company. At Axon, we try to unify it and to use exactly the same supplementary tools despite the project, and it really helps to quickly jump between projects. But when we when new candidates, new developers come to Axon, they say, "Oh, I'm not used to write like the code like this. In the previous company, we did it another way," and that's the price we need to pay for React. It gives flexibility, but with it we pay with a steep learning curve. That's the truth. Then I want to explain you what are meta frameworks. You may not heard this before, but it's quite popular slang word in the front-end world. Imagine that we have a framework, and imagine that our application needs a search engine optimization. So it should be server-side rendered. This requirement brings unavoidable complexities. It's not easy to make your application rendered on the client side and on the server side at the same time. And to overcome this complexity, people started inventing meta frameworks. Meta framework consists of the framework itself, like React, plus a bunch of abstractions for server-side rendering, for static site generation, routing, styling, maybe some shared layouts, and a lot of other different abstractions that simplify our way to render it on the server or pre-render it. So here are the most prominent examples of meta frameworks. The first three, Next.js, Remix, Gatsby, they are based on React. That's why they are in blue color. The Next.js is similar to Next.js, but it's for Vue.js framework. There is an Angular Universal to render Angular on the server side. Actually, I cannot consider it to be meta framework, but this is at least something that we have in Angular. Other frameworks are more, they went far than Angular in terms of server-side rendering. They can do more, they are more performant, especially the React-based ones. Yeah, then we have Svelte Kit, which is based on Svelte, which is an experimental tool, and you should not use it for commercial reasons, commercial projects. And Astra 2, it has great idea to pre-render content, to minimize the number of JavaScript passed to the client side, but it's way too early to use it in commercial projects. And then if you think that this is difficult to understand, if you think that maybe you don't need meta framework, at this moment meta framework appear. And meta frameworks, they are even more opinionated. They are less customizable, but they are super specific. For example, tools like Hydrogen, Dokusaurus, Blitz JavaScript, they are built on top of React, on top of Next.js, and there is one more layer of abstraction that makes it perfect for some specific needs. For example, Hydrogen is for building Shopify-based stores, so it's for e-commerce websites. DocuSaurus, it's a great tool for building documentation websites. And Blitz.js is something to connect your Next.js application with the built-in server, auto-generated server. So you don't need to write the API where it will be generated, and you can save the data to database directly from the client, calling some kind of remote procedures. It's out of scope of this presentation. Yeah, so these frameworks, they require some knowledge of Node.js. But then comes the question, do I need full stack JavaScript developers in my team? Yeah, do I need Node.js developers, or front-end devs can handle it by themselves? That's a good question, and let's talk about the team now. An ideal team. Whether you are a team manager or a team leader, you'd probably have a dream of composing your team of senior developers. Many vacancies say that they need a developer with 5+ years of experience in React. Breathe out. Throughout my 4-year recruitment experience, I've seen so many developers who claim themselves having 5 or more years of experience, but they were unable to talk about anything outside of their direct job responsibilities. They might know their frameworks well, but when it comes to solving some different situation, creating some innovation or leaving their comfort zone, it doesn't work. That's why I have my own vision of the perfect candidate, perfect front-end candidate that you probably may want to hire to find. So the perfect candidate, in my opinion, is first of all T-shaped. They do not panic when they receive a task that involves learning anything out of their direct job responsibilities. Because when you ask a front-end developer to learn something new, to maybe go look how this meta framework works, how it interacts with the server, they can panic like, oh, I don't know server-side development. Well, you have to learn it. You need to be T-shaped. You need to understand how things outside of the front-end world works. And there is another thing that can help being T-shaped, is having a computer science background. So maybe your candidate has a computer science background or is obtaining it right now. Why it's important? Because right now it's very straightforward to jump to web development these days. Building trivial websites is easy. It's well-skilled work, and you've learned the language, you've learned the framework, and you're good to go. But building apps that will live for years, the large-scale apps, it requires detailed architecture study. It's not enough to finish some courses and learn the framework. No. You need to know much more than that. And the team which lacks at least one developer with computer science background can become a bottleneck long term. So try to keep at least one outstanding person per development team, a person whom you are sure of. That's my opinion. Next, I want to talk about the full stack developers. So they exist. That's fact number 1. But fact number 2, you might not need them. Why? You need to find a way to differentiate between developers who claim that they know how the backend works and developers who can apply their knowledge, who can do both front end and back end at the same time. And it's not the same. Yeah, knowing how it works and applying it in practice are different skills. For example, I can write server-side code. I can I can complete tasks of probably average complexity, but I can't say that it makes me a full stack developer, though I know many different programming languages, because I don't have enough practice, And I think that front-end developers, they need to be more focused, because front-end development is difficult. It's not just to create a markup to style it with CSS. No, it's much more if we are talking about the large-scale products. So more focus brings us better quality and less burnout, because when you are overwhelmed with all this information, you need to think about the front end, the back end, the API, the CSS, the database, you will burn out. Well, and one important thing to know is that applying server-side rendering, like using the Next.js framework to render your pages on the server, it doesn't make you a full-stack developer. No, it's not about backend at all. It is some kind of server, but it's not that difficult. It's not about the API, it's not about the database, cache and query. No, it's a bit simpler, so it doesn't make you a full stack. You're still a front-end developer. And now, as we finished with this topic, if you have any questions, let me know. I'm still reading the chat. Let's jump to the next important question. It's about languages. So front-end languages. There is a big dilemma on the front-end side. There is one obvious fact that browsers run only JavaScript. And WebAssembly, but this is out of the scope, JavaScript is a terrible language. But there is a good fact that everything can be transpiled to JavaScript. Any popular language, whether it be Clojure, Java, Kotlin, Swift, anything can be transpiled to JavaScript. Another good thing is that TypeScript adoption is growing. It's growing rapidly. And many companies, different companies, including Axon, use TypeScript to try to achieve more type safety. Yeah, why do we need another languages? Because they offer more type safety. But there is another terrible point, that TypeScript gives us false safety. It's unsound language, and compared to other languages like RESTscript or, I don't know, Kotlin, TypeScript is unsound. It doesn't give us safety. And the question arises, why do we still need to use TypeScript? And the answer is simple. It's a snowball effect. Yeah, we use TypeScript because it's snowballed, it's balanced. It found the balance between productivity and soundness and the correctness of the types. So that's why many companies are switching to TypeScript these days. And I think that you should at least use this side by side with your JavaScript code, like type definitions, writing type definitions, or at most you should try to write the entire code base in TypeScript. At Axon, we've been using it for 5 years, and we've been using it on absolutely all kinds of projects for the last 4 years, and we are absolutely satisfied with it. But you need to remember that TypeScript is not sound. It comes with pitfalls, and you should know about these pitfalls. First of all, the team must understand the non-goals of TypeScript. You can find these non-goals in their documentation website somewhere on GitHub. Second, the team must learn how to prevent the unsound code. Some time ago, I did a presentation, another webinar where I named it The Dark Side of TypeScript, and we covered about 10 or 15 different scenarios we can apply to make the code more sound. And then at least one member in your team must have a solid experience with TypeScript. Otherwise, it's better to pick JavaScript, because when none of developers know TypeScript, they will write very, very poor quality code, and it's better to get rid of TypeScript and go plain JavaScript. It will save your time and money. So have at least one experienced developer in your team. And also, you should not neglect other safety techniques, such as testing, like unit testing, because the statically typed language, it doesn't save you from all the problems. No, it saves you from one small portion of problems, like type safety. But to make sure that your application works well, you need to cover it with tests. But it also depends on the size of the project, because if you're writing something small, like 5 or 10 page based application, then you probably don't need to write tests, because it's small, it will die soon probably. Yeah, if it's a large scale project, feel free to write tests. Otherwise, it's questionable. And now, I hope you are still here with me. Yeah, I see all 20 persons in the chat, cool. The last topic, it's like a bonus topic about switching teams. So, what does it mean? People come and go, and if your project is built to live for years, you must understand that it will go through many generations of developers. Sometimes changes are sudden, or they're often sudden, and the receiving team often doesn't have enough time to acquire the knowledge from the team who's leaving the company. And the worst scenario that we experience often is when the whole team leaves the project without leaving any documentation after them. And that's why we need to go and apply reverse engineering. We need to understand the user flow, the architectural patterns, and while everything is recoverable, it's very time consuming. So be ready that at your project that you're working right now, the team with whom you're working on, it may leave. You may change vendors, and be prepared for that. How to prepare, how to make certain that your business won't suffer from transferring project from one team to another. You must be proactive. You must make sure that the current team uses widespread tools with large communities, because when they use unknown tools, their own frameworks, their own architectures, how to support it, how to maintain, how to continue the development. So be sure that your vendors, your team uses widespread tools. Make sure that they do not invent own hacks, abstractions, pure fabrication code, which is a code that is not related to the business domain, but only complicates the code base. Make sure that they don't invent it, because it happens very often. You open a new project, you don't have any documentation, and you're like, how to deal with it? I don't understand anything. Why did they use this framework? Why did they use that library? And that's why the most important point is to maintain documentation. Make sure that your team writes documentation. It's not about the code comments, like documentation in the code, but the documentation in general. Why this or that tool was chosen? Why did they do this architectural decision? Because it's very difficult to reverse engineer the ideas behind certain actions. And also, while transferring the project, the new team will likely complain about the technologies that they see. Like when you transfer to another team, it sees the project and they can say, No, we don't want to work with these tools. We need to rewrite everything from scratch. Yeah, and that's why I did the next slide about rewriting from scratch. It's a good idea. It makes absolute sense in a single scenario. If a project size is small enough to do it quickly, because otherwise, think about the resources and the consequences. First, does the business have enough time and money to rewrite the application right now? Probably no. Will it bring any value long term? Probably it will, because your team is has more experience with this framework, with these tools. But still, the first question remains: do you have time and money to rewrite? Do you really need to do it? And remember that except for time and money, you also need to create a plan. You need a complete vision. Why do you need to rewrite it from scratch? Isn't it easier to just go and read the documentation to understand their decisions? Then you need qualified engineers, because if you don't have a qualified team who can see why certain decisions were made, it would be extremely difficult to migrate the application, to rewrite it being equal, with equal possibilities. You may miss something and it will harm the business. And after all, it should be an iterative process. You need to rewrite side by side. You cannot just postpone your backlog and start rewriting the app from scratch. No, you need to do it in parallel. So rewriting it's a tedious process, and you should think twice before offering it if you're a development team, or before accepting it if you are a business owner. Well, we talked about frameworks, languages, people, projects, and almost 1 hour passed. Wow. I know it could be difficult to track, so feel free to scroll back in time and to review my slides, my presentation. And also, 2 years ago, I did an article which is called Choosing a Technology Stack for a Web Application. It's kind of similar to what I presented to you today. And if you want to understand more, this article is still relevant. So you can scan it with your phone and read. It's on our axon.dev website. So this way you can consolidate your knowledge. I think that's all from my side. And if you guys want to if you didn't understand anything and you want to have a consultation, so feel free to reach me out in LinkedIn or any other social network. If you can find me, I will be glad to help you. Yeah, and to work with you, maybe if you're a business owner, if you need some kind of front end or full stack project, just let us know. Thank you, everyone. If you have any questions, let me know in the chat. If not, that's great. Okay, I'm finishing this presentation, this recording, streaming. So thank you, everyone. once again, and see you, if you are from Axon, see you on the stand-up tomorrow. Have a